Each photo interpretation, or PI station in the IOIC, provides the operators with visual information and data that have always been the working material of photo intelligence. But by automation, this station eliminates time-consuming mechanical and mathematical work. It helps the operator to convert raw data into useful intelligence much more rapidly than he formerly could. This film will show the PI station and its equipment in use. It will explain the various computer programs the operator can employ in order to do his job. The IOIC has 3 identical PI stations, one of which is adjacent to the station of the electronic evaluator. The PI stations are linked to electronic equipment in the adjoining Electronic Data Processing Area, or EDP. Each station is connected to its own ANUIK1 computer, K1 for short, in the EDP. The K1 handles the PI programs. Therefore, it is an integral part of the photo intelligence capability. Each K1 has 3 input-output channels designated A, B, and C. Channel A handles data to and from the stereometric comparison viewer, or SCV, through the input-output adapter. This adapter is simply a hookup that makes the K1 and the SCV electrically compatible as they are manufactured by different companies. The stereometric comparison viewer facilitates viewing of photographic material. Film can be run through rapidly with various automatic search aids. On the SCV, any frame of photography can be magnified rapidly, and the image can be rotated. This makes it a simple matter to orient oblique and panoramic pictures properly. 2 operators can make good use of the viewer for comparative study of an area. Working together, they can compare pictures of an area or point of interest made by one sensor, such as this side oblique photo of a Vietnamese coastal area, with the same area obtained by side-looking radar. Or of an area, such as the SAM site, rephotographed 3 days later. It permits extremely accurate automatic measurements of images on film. These film measurements are transposed into actual measurements by the computer programs and presented in automatic displays that can be accurate within 1 foot. The photography employed in this system is unique in that each frame is imprinted with a code matrix block that is read by the SCV and the information passed into the computer. The block contains navigational data, time, latitude and longitude, radar altitude, and barometric altitude, aircraft orientation data, heading, drift, roll, pitch, and administrative data, date, detachment, squadron, sortie, sensor identification, SLR mode if applicable. The equipment reads this data and presents it on the viewer display panel. Channel B in the K1 connects through the control signal converter, CSC for short, to the AN USQ20 computer, known as the Q20. The Q20 is connected in turn to the magnetic tape units, MTUs they're called. The MTUs are auxiliary memory equipments. They allow more programs to be used in the system through their linkage with the Q20 computer. Channel C in the K1 connects the computer through the controller to any of 3 equipments. The controller is simply a switching device that makes the connection to the equipment selected. One of the equipments is the digital plotter. This is a plotting device that provides a rapid means of presenting intelligence data graphically. It plots geographic points automatically based on information provided by the computer from other sources, such as the code matrix block or the database. In addition, letter, number, or order of battle symbols can be annotated on the plot. Channel C also connects to the station's teletypewriter. It enables the operator to input data to the computer during operation of the station programs and to receive output data from the computer. And finally, this channel connects through the program request panel electronics to the program request panel. Although it is physically located on the stereometric comparison viewer, the program request panel is actually a separate unit. It gives either operator the means of selecting the program he wants to employ and the way he wants the results presented, as a teletype printout or digital plot or whatever. The program request panel electronics is a gray box to which the program request actually goes. This unit then gives the computer the electronic code for the requested program. This, then, is the PI station system. The K1 computer, as an integral part of the system, connecting through channel A to the stereo comparison viewer, through channel B to the Q20 computer and its linkage with the magnetic tape units, and through channel C to the digital plotter, the teletypewriter, and the program request panel and its associated electronics unit. The PI operator can put this system to work in various ways by selecting and using the appropriate program. To see what the system is capable of doing, we'll examine some of these programs. All the programs are permanently written onto magnetic tape for selection at will. Before the PI station can be properly operated on line with the computer, the operator must ensure that the proper library program is being used. And he sees that all the equipments are connected and turned on. He then has a preparatory program to execute. The pre-mission entry program gives the computer the fixed data it needs before it can handle any of the operational programs. This data includes such information as the kind of map being used on the digital plotter, its scale, and the coordinates of the area covered. It gives the type of sensor photography installed in the viewer. It also includes a listing of information that is wanted in order of battle plots, feeds in any supplementary data that the computer should include in its output, and gives a variety of administrative fixed data. To give this needed data to the computer, the operator initiates the pre-mission entry program. All programs are initiated in the same manner. Press the buttons for the wanted program, the means of input, and the side of the station being operated. Then press the transmit button. When the computer is ready with the program, it gives a light signal. The data on the tapes is fed to the computer via the teletype. Another preparatory program enables the operator to give the computer the code matrix data that is on the film so that the computer can use it subsequently with other programs. With the code matrix block properly positioned, the code matrix data entry program is requested. The operator can, if he wishes, also select the magnetic tape or teletypewriter output options. The code matrix reader presents the code matrix information on the data display panel. If the mag tape option has been selected, all the code block information from a roll of film is stored on magnetic tape. If the teletype option has been selected, the computer gives a teletype printout of the code matrix data. Sometimes the code matrix blocks may be found to contain errors in navigational data. If so, the computer can be given information that will enable it to correct these errors automatically. The pre-mission entry program has already stored accurate geographic coordinates of checkpoints in the computer, and these have been plotted on the digital plotter. They represent well-known places or objects easily found in the photography. As each of these familiar points with precisely known geographic coordinates is now located on the viewer, the code matrix data for the frame of photography containing it is entered into the computer via the code matrix data entry program. By means of programs that are explained later, a plot of these points, based on the code matrix block data, is made for correlating with the checkpoints already accurately plotted. This is the error. The operator now makes use of the correct navigation program. The program calculates the difference between the known actual coordinates and the computed coordinates from information in the code matrix block and stores the corrections. If desired, a teletype output of the corrections can be obtained. In this case, the corrections are 2 minutes, 31 seconds north, 1 minute, 24 seconds west. Where corrections have been made for 2 or more such frames, the correction table in the computer will be used to interpolate for all intermediate frames of photography for the same flight. A different capability is contained in the frame search program, which makes it possible to search automatically all types of reconnaissance photography and locate specific points of interest. It often involves correlation with the electronic evaluator. For instance, supposing the EE has an emitter location narrowed down to a small ellipse which is suspected to be fire control for a AAA site. He notes the coordinates of the possible location and takes the problem to the PI operators. He asks them to make a visual check of the estimated position. In order to find the frames of photography in which this probable site appears, the PI stores the coordinates to be searched using the pre-mission entry program. The PI requests the frame search program. When the computer has loaded the program, it drives the film through the viewer. With this program, the computer receives the code block data for each frame in sequence and calculates the area covered by the frame. When the computer locates a frame containing the coordinates being sought, it positions that frame in the viewer. The operator can then study the picture. If the operator cannot readily see the site he is looking for, he initiates the Priority Point Drive program. With this program, the computer gives the XY coordinate information to the viewer, and the frame is moved to bring the precise geographic point under the crosshairs. Now, when this point is enlarged, the operator is able to spot the site. These equipments and programs can also be used to obtain a variety of measurements. The mensuration programs rectify all photography automatically, eliminating time-consuming manual rectification. First, the preparatory mensuration entry program must be executed. The operator drives one of the fiducials under the crosshairs and resets the mensuration counters to 0 and stores these coordinates in the computer. He repeats for the other fiducials, 3 for frame photography and SLR, and 2 for panoramic photography. When the computer has all the fiducials stored, it solves the rectification problem. Then additional points can be stored in order to make measurements. The first point of interest is driven under the crosshairs. Let's say it's one side of an oil tank that we want to measure for diameter. The mensuration entry procedure is again used to store the coordinates for that point in the computer. The operation is repeated for the other side of the tank. Now the operator follows the distance azimuth program procedure. In effect, he asks the computer to measure the diameter of the tank. The computer calculates the actual ground distance length and automatically displays distance and direction of measurement on the display panel. 107 feet, 237 degrees, 56.0 minutes. If the teletype output option has also been selected, the computer outputs the data to the teletypewriter for reproduction in hard copy form. To measure the height of the same tank, the height program is employed in a procedure similar to that for other mensuration programs. Now let's suppose that the operator is interested in determining the area of a building associated with the same tank. He again initiates the mensuration entry program to clear the previous filmed coordinates from the computer. Then he stores the coordinates for each corner of the building in the computer. In this program, the computer will handle up to a 6-sided enclosure. Then he executes the area program, and the computer gives the answer: 3,382 square feet. Again, if desired, the information is also obtainable as a teletype printout. With the location program, the computer calculates and displays the geographic coordinates of any point in the frame. For example, the POL storage area is marked for destruction, and it is important to know its exact latitude and longitude. After the fiducials have been set in, the point is brought under the crosshairs. Its position on the frame is given to the computer. In operation, this program is like that for the other mensuration programs, except that in addition, a plot output is available. The computer displays the geographic position of the POL storage area: 20 degrees, 52.5 minutes north, 106 degrees, 39.9 minutes east. If the plot option has been selected, the computer outputs instructions to the plotter to place a dot on the chart at that geographic location. The operator now wants to annotate the dot that has been placed on the chart in order to identify it. He does this with the Location ID plot program. When the operator initiates this program, the computer outputs a message to the teletype asking for an input as to the type of identification wanted. The choices are 3: alphanumeric information, as at the top, or a specific symbol, like the AAA in the center, or geographic coordinates, as at the bottom. In this case, the operator calls for alphanumeric to name the storage area. The target location sketch program makes it possible to produce a sketch on the plotter from objects on a photograph framed in the SCV, a road, for example. The sketch is made as a series of dots by moving the outline of the object under the crosshairs and plotting the coordinates of each new position. The operator makes the sketch by connecting the dots with a line. Thus, a new highway can be added to a chart that is being updated, or a new airfield, or a military installation, and so on. The point plot program is frequently used in mission planning, for this is the one that enables the operator to obtain an order of battle plot. Information obtained in a storage and retrieval search and written on magnetic tape is used as the input to this program. The operator can ask for and obtain any specific order of battle for any geographic area he wants, or he can obtain a general order of battle. Various other programs are available and have their good uses. Among them are the flight path plot and MITRAN programs. With the flight path plot program, the operator can plot the flight path of the reconnaissance aircraft. For each frame of photography, the code matrix block is read and the aircraft position is plotted. By plotting each position on the plotter and then connecting the points, a continuous flight path can be put on the chart. Finally, with the MITRAN program, the computer provides some of the help needed in formatting data to identify, prepare, and index frames of photography that are to be placed on MITRANs for future use. This information is given to the SNR area for indexing the film in the database. We have seen that the computerized photo interpretation programs allow rapid, accurate evaluation of aerial photography during tactical operations. The programs and the equipment that carries them out provide the operators with a highly versatile and useful PI system. But the computer, of course, cannot make decisions, nor can it utilize the interpretation experience of the operators. Those decisions and the utilization of accumulated experience continue to be the responsibility of the men who operate the equipment.